Hello friends, welcome to my channel Civil Structures. In our last video, we have considered one example of continuous beam. You can see here, this beam we are analyzing using moment distribution method. See, here is the procedure for analysis of continuous beam using moment distribution method. In our last video, we have completed our step number 1 and step number 2, and they are fixed moments and distribution factor. See, these are the values for the fixed moment, and here is a distribution factor table. Correct? Now in this video we will continue our example with step number 3, and that is find support moments using moment distribution table. Before starting video, please subscribe my channel for more updates. For academic consultation on civil engineering subjects, thesis or academic projects, you can contact me on civil.structures2018@gmail.com. If you like our videos and want to appreciate our efforts, then you can help with your generous donation on civil structures at UPI. Correct? Okay, after calculation of distribution factor, our next step is to determine support moments using moment distribution table. Okay, so first let's see how will we prepare our moment distribution table. Okay, so here is a moment distribution table. In the first column I have written informations regarding joints, member, DF as in distribution factor, FEM is fixed moments, balance carryover. So this balance and carryover which comes in the iterations. So this balance and carryover moment which is for our iteration number 1, and this type of iteration we have to proceed at least 3 to 4. Correct? Okay, now let's fill this table. Right. For joint number A, we have only one span, AB. For joint number B, we have two spans, BA and BC. Correct? See, always remember, for intermediate joints, we are taking two spans in right direction also and in left direction also. Correct? So which is intermediate joints will be connected with the two adjacent other joints. So we are considering in right direction also and in left direction also. So for joint B, we are taking B to A also and B to C. Same for C, it is C to B and C to D. In the last joint D, it has having only one member, DC. Correct? Now let's put the distribution factor. So distribution factor we have calculate for BA, that is 0.56. BA 0.56. For this we are putting 0.44 for BC. Correct? For BC distribution factor is 0.44, and for joint number C, CB and CD both are having same DF, that is 0.5. So I'm putting here the values 0.5 and 0.5. Correct? Now let's talk about member AB and member DC, which are the external joints, or we can say which are the end joints. Now always remember, distribution factor for the end joints, if the end joints are fixed, then the distribution factor value is 0. Okay? And if external joints having hinge support, then distribution factor for the external joints are 1. But in this example, our joint A and joint D both are fixed, both are having fixed support. So I'm putting the distribution factor value is 0. Correct? Now next row is for FEM, that is a fixed end moments. So whatever fixed end moments we have calculated, let's put them one by one. Right? So for member AB, my fixed end moment is minus 25, and for BA it is 20. So I'm putting here minus 25, and for BA it is plus 25. Okay. Now for BC and CB. BC and CB it is minus 31.25 plus 31.25. And for the last two members, for CD and DC, both are having the different values, minus 57.4 and 38.4. Okay, right? Fine. Now we have to start with, okay, So what we have to do first of all, we are preparing this type of table. For the first column, we are putting some informations regarding joints, member, DF. So basically which values we are providing in that particular row, FEM, balance and carryover. So what is the balance and carryover? I'll explain you here. Till here, we are putting each and every value what we have determined till now. But now we are starting with the iteration cycle. Okay, so now let's start with first iteration. For joint A, the distribution factor is 0. So for now we are not considering this. We are starting with only intermediate joint, that is B. Okay. So for this, first of all, we are considering these two values for BA and BC. Fixed end moment for BA and BC for the same joint, for the common joint. Okay. What I'm doing here, I'm adding both of this value. Adding with the cumulative, adding, that means with the sign convention as it is. So what I'm doing, adding both the values, correct? 25 minus 31.25, that is minus 6.25, correct? Minus 6.25, this value should be multiplied with distribution factor for both of the members individually, for both of the members respectively. So let me tell you, for BA, minus 6.25 multiplied by 0.56. What is the answer here? Minus 6.25 into 0.56. It is minus 3.5. But we are putting this value here with different sign, with the sign change. So what I am doing here, minus 3.5, and it will be converted to 3.5. So I am putting here in balance, BA is 3.5. Now let's see for the span BC. Again we are talking for the joint B only. So we are discussing among these two values only. We are just adding both of them with cumulative summation 25 minus 31.25, that is minus 6.25. Now this now for span BC, what we are doing, minus 6.25 multiplied by 0.44. This value is minus 2.74. But as we discussed earlier, we are putting the value with a different sign. So finally my answer is positive 2.75. 2.75. Correct? Now next, see for the joint number C. Correct? Second intermediate joint is C. And how many members are connected? CB and CD. And these are the distribution factor. This is a fixed end moment for this particular span. Now what we need to do to balance, first we need to do the cumulative summation for these two values, 31.25 minus 57.4, and that is minus 26.15. Now this minus 21.65 for span CB, we need to multiply with the distribution factor. Distribution factor value is 0.5, and here the value is minus 13.07, right? And we are putting the opposite sign here, 13.07. So I'm putting here 13.07. Correct? Now next is for span CD. Same process we need to do. Cumulative summation 31.25 minus 57.4. That is, we have already done this, minus 26.15 minus 26.15, and for span CD we are doing minus 26.15 into 0.5. So what is the answer? Minus 13.07, and for this table we are putting the opposite sign than what we have calculated here. So that is why I am putting the 13.07 values. Now What about AB and DC? Now in the balance row, the distribution factor with the zeros members AB and DC will be having the value 0. Now our next row is carryover. Okay. Now for the carryover moments, if the far end is fixed or continuous, we have to carry over 50% of the moment with the same sign. And if the far end is not continuous, then there is no transfer of moments. Now let's understand what they are saying. Far end for the joint B is A, and that is fixed and continuous. So what happened here? We have to do 50% of the carryover. 50% it means divided by 2. So I am taking here carryover like this from BA to AB, or we can say from joint B to joint A. So here I am doing 3.5 by 2. It is 1.75. And same we are taking from AB to BA. This value is 0. We have to put it 0 here. Now let's talk about joint C. Far end joint of C is B. Far end point for the joint C is B and D both. I'm taking carryover 50% from this to this, and definitely far end from B to C, B is also from far end of the B is also C. So we have to take 50% carryover like this. We are taking 13.07 by 2 here. It is 6.53, and for and 2.75 divided by 2 is 1.375. Correct? And for this member we are taking, for this CD and DC member we are taking like this. C to D and D to C. So definitely this value is 0, correct? And this value is 6.53. Okay. So here our iteration number 1 is done. Now let's proceed with iteration number 2. Okay, so now let's move to the iteration number 2. For second iteration, we need to take these two values for joint number B, right? So procedure is same as in iteration number 1. For joint number B, we have considered two fixed and moment values. Now we are taking these two values, right? So as per our procedure, we need to do the cumulative summation of these two values, that is 0 plus 6.53. 6.53. Now this 6.53 for span A should be multiplied with the distribution factor, and that is 0.56. Okay, so the answer is here 3.65, and we already know that we are putting the value with a opposite sign. So I am putting here minus 3.65. So I am putting here minus 3.65. Now iteration number 2 for span BC, we are taking cumulative summation for these two carryover moments 6.53, and for span BC we need to multiply this value with distribution factor of BC, and that is 0.44. So here my answer is 2.87, and we are putting here opposite sign of 2.87. Okay, next we are taking iteration number 2 for joint C, and for that we are taking these two values carryover moment for the joint C, right? So we are doing the cumulative summation 1.375 plus 0 is equal to 1.375, right? And for the span CB, what we are doing 1.375 multiplied by the distribution factor, and that is 0.5. The answer is 0.68. Answer is 0.687. So here I am putting 0.687 with the opposite sign. Now for span CD, Again we are doing cumulative summation of carryover moment values 1.375. For span CD, we just need to multiply this value with the distribution factor for CD, and that is 0.5. Here also same answer we are taking 0.687, and also we are taking with the opposite sign. Now next step is to take carryover for iteration number 2. What we are doing, we just carry out the moment from B to A and A to B with the same sign. Here minus 3.65 divided by 2, it is minus 1.825, and this will be 0. Now again we are doing same process with B to C and C to B. 0.687 divided by 2, which is minus 0.343. It is minus 1.435. Here we are taking minus 1.435, and this is 0. And here for joint C and D we are taking carryover moment. This will be 0, and half of this value is minus 0.343. Okay, so see, here are the complete values for the iteration number 2. Now for iteration number 3 and iteration number 4 will be the same process. You can see here is the complete moment distribution table with 4 iterations. Okay, and here is the iteration number 1. This is my iteration number 2. This is third one, and this is iteration number 4. Now finally we have to calculate total support moments by summation of some values. Now which values we need to do use in summation? Okay, from fixed moments, each and every value we are doing with the cumulative summation. Okay, so for here, for joint number A, minus 25 plus 0 plus 1.75 minus 1.825 plus 0 plus 0.096 minus 0.10, and here my answer is minus 25.08. Now for joint B, here we are from this point we are taking, so fixed moment for the joint B, BA will be 25, BA is 25 plus 3.5. See here, all of this value we need to do cumulative summation. Plus 0.35 minus 3.65 plus 0.192 minus 0.20, and it give me the value 24.84. And next we are taking span BC, minus 31.25. We are considering from this value, right? Each and every value we are putting, we are doing with cumulative, and this answer is minus 24.84. Now for joint number C, this answer is minus 44.29. For CD, after doing cumulative summation, this answer is positive 44.29. And the last one is 44.95. Correct? Okay. So these are our support moments. This is a value for moment at AB. This is for moment at BA, for BC, CB, CD and DC. Correct? Okay. Now here there is one check we need to do. How can we understand that our moment distribution method or moment distribution table is correct? So for intermediate joints are B and C. What are the values for both of the span of intermediate values? This one is 24.85 and this one is minus 24. For BA it is 24.84 and for BC it is minus 24.84, right? So both of the summation of BA and BC, cumulative summation should be 0. And if you see this, here our calculation is correct. And same for the intermediate joint number C, minus 44.29 plus 44.29, correct? When you do the cumulative summation, both of this value, they will give you 0, correct? So here our moment distribution table is Correct. Okay, and here you can see these are the total support moments. Correct. Moment at AB, moment BA, BC, CB, CD and DC, which we calculated from the moment distribution table. And this is how we can determine support moments of the continuous beam using moment distribution method. In next video, we will continue with our next steps of procedure for the moment distribution method.